Okay, I guess we can get started. I'm Chaz Boyd. I work on graphics on the Windows team. We've been working on Direct3D for a while, and this is the story of how that ties into your Metro game. So the thing I want to point out initially here is that the game space is pretty huge. If you want to write an application that gets a lot of customers, the games are really running near the top of the charts right now. In total, the game space, counting console games and handheld games and so on, is in the several billions of dollars. It's up there with the movie business. Some days it's ahead, some days it's a little bit behind if they have a blockbuster movie and you don't count memory sticks. But in the United States alone, there are estimated to be that many people who play games. That counts people playing Solitaire and Minesweeper, 150 million or so. And the other statistic that was interesting is when we look at app stores, current, quote, apps that are out there today, it looks like the majority of the downloaded applications that we see today are actually games. If you take every other category, system utilities and media players and so on, and add them all up, it doesn't count as many downloads as just games. And the situation is growing more so because originally the PC started out as something that you used at work and then people brought them home and so on. But now what happens is as the PCs become smaller and lighter and more portable, people have them with them more of the time. So the opportunity that they have as part of their leisure time is even greater. So the central point I'd like to make here is that the new platform for Windows 8 will deliver you guys everything you need to create a game and potentially ship it to millions of customers. So what I'm going to try to do is run a little demonstration here of a game that's already on the platform. So if you guys wanted to, you could go to the App Hub right now, download it, install it on your machine, double-click on the solution file, hit F5, and play along with me for the audience participation part of today's talk. But I'm not going to make you do that. But it is something to keep in mind that, what I'm talking about today is not entirely made up. So here you can see the App Hub. There's where it is. I'm going to switch to my Task Manager, Start menu. And there's the Marble Maze icon. We'll start that up. Now, this is an accelerometer-based game, so it's going to be a little bit tricky for me to play with all of the umbilicals on me, but this is pretty much how it works. It's a labyrinth-style application. It's got full audio. It's even got sound effects depending on the velocity of the ball, clacking noise when it bumps up against the walls, a variety of different input mechanisms, which we'll talk about in a bit, and then checkpoints that mark your progress when you're partway through a level. We'll talk about all of these during the presentation today. It's also playing background music, and it really needs somebody good to play it, I think. Okay. So, as I pointed out, there are quite a few components that you'd really like to have if you're going to start to write a game. And our platform, my objective is to prove to you today that the platform contains the types of components that you would need to be successful at creating a game. Pretty much every game is going to need some graphics technology, and sometimes there's 3D graphics or 2D graphics in the same game. It's going to need, in some cases, UI controls that you can use to control options for the player, for example. Every game has to have input. If there's no input, it's just a movie. So now we're seeing, with these natural user interface technologies, a much richer variety of input technologies provided for games that range from touch and accelerometers all the way up to joysticks and even steering wheels in some cases. A real game is trying to simulate an immersive experience like the real world. That's really one of the objectives in a lot of games, is to be somewhat realistic. And so you need audio, you need sound effects, you need cues for the user when different events happen in the application. And you need, in many cases, people will augment their game by providing high-quality graphics in the form of movies or cutscenes that help the user really connect with that at a very high-quality visual level. And then we're getting into the category of services that a variety of pretty much all applications need. They need a good way to get launched and be found by the user. They need ways to persist state from the progress that the character or the player has made through the game. They need other interfaces into the operating system to be considered realistic applications. And then this is the connected era of that thing called the interweb. And there are a variety of interesting services that offers that are also very interesting for games to adopt as well. And then fundamentally, in the process of building a game, you are going to need tools and compilers, debuggers, and actually in the real production space, the majority of code that a game shop creates is around their art pipeline tools process, not the actual code that ships in the box. So we would like to show to you that we've got offerings in all of these areas that will be important for your efforts at making a game. But first, while we're on the topic of tools, I wanted to see a breakdown, potentially show of hands on how many people would like to write a game in, say, C#. Okay, how many are interested in writing a game in HTML5? That's a good number. How many people would like to write a game in C++? Okay, that's a really good number as well. It looks pretty evenly matched. One of the things I'd like to do is if you're really someone who wants to get started at this right away, then you should come down and talk to us at the end of this as part of the Q&A session, and we'll maybe find out a little bit more about what your plans are. I lost my controller. Okay, so this slide here is really sort of an outline of the rest of this talk, and in some sense, it acts as kind of an index into the technologies that we're offering at this conference that will be relevant to the game scenario. And what I'm going to do in many cases is refer you to another talk where there'll be an expert on that technology, but I'll try to put a little bit of a spin on that particular technology from the game's perspective. Okay, so the first core technology, you've got to have cool graphics, even if it's just a cool-looking sprite. And that's because visual immersion is an important part of entertainment in a lot of cases. DirectX is our solution for this. I know every component that's already underlying the Windows 8 platform is really fundamentally based on graphics today, the DirectX graphics stack. But if you code against that at the direct level, as opposed to going through an existing framework, you get much finer control over the hardware and over the performance and latencies of your interaction. I really can't stress that enough. The difference between an interactive experience and a not interactive one is really how long it takes for you to provide the response to the user based on the input that they just provided. And that metric, that you can almost boil it down to a fixed number of milliseconds, is really key to the quality of the experience. And so a lot of what we're talking about today will be how do we make sure that our applications are as interactive and responsive in that sense as they can possibly be. And it's a little bit non-intuitive that having responsive input depends on graphics, but practically the graphics is one of the most important parts of that, because some of the longest time between when you get your input and when you put your data on the screen is spent during the graphics phase. The processing of touch and so on is a relatively small portion today. But to get a good touch experience, it means that your graphics technology has to be efficient. And that's why Direct3D is our solution for the graphics problem in this space. It's been successful in the marketplace. There are a lot of AAA titles out there shipping on it today. The point for you guys is you may be making a $1 application, but you have access to the same technology that a high-end AAA title has today. And then, we're betting on Direct3D. Our platform is strongly attached to that or built on that from the ground up. And as a result, we're going to guarantee that all the Windows 8 devices have good D3D support in the box. Otherwise, they wouldn't be shipping Windows 8 devices. So also, there's a specific talk about Direct3D and some of the more detailed changes that we made to that API over the last few years. That'll be tomorrow around lunchtime. The other thing I wanted to point out is that now that the PC devices are spanning a broader range of, say, portability from a small device like the one you received all the way up to, three-way SLI boxes, there's more of a opportunity to span a broader market. The Windows install base of potentially hundreds of millions to billions of customers, some cases have a variety of situations that they want to use their PC, and sometimes it's just on their lap in the car, sometimes it's home in their den, and they have a range of performance levels that they want to leverage in those cases. So we have a separate talk tomorrow after Friday on how to balance your performance across a range of hardware. So there are a lot of games out there today, especially in the casual space, that are using 2D graphics. A surprising number of those 2D games actually implement their tech using 3D APIs. But Direct3D is based on Direct3D, and so it offers a much more efficient syntactic mechanism to do things like sprite-based objects, and in some cases, even imaging effects. Even 3D games are going to use some elements of 2D just to show your high score, or your current score, and your health bar, and things like that. So Direct2D is our solution for that. It's highly optimized. It's optimized for drawing 2D structured graphics. It has image effects and also text, which is implemented using DirectWrite. And that's one of the advantages to that approach, is that it's easy to localize. If you want to target 1 billion customers, you're going to be in a variety of different locales. So using a text API that's easily localizable will help a lot there. The interesting thing is that the way we've set up Direct3D and Direct2D in this release, they're all sharing underlying technology in a very efficient way. And that means that you can switch back and forth between those calls fairly efficiently, to the extent that you can see how that works in all of our samples. All of the logos on all the sample apps, even the D3D sample apps, use Direct2D for their 2D art. Okay, now input. Like I said, input is pretty important, and it's the other end of the end-to-end experience from the graphics side. We've got a new set of APIs for touch in Windows 8. These are provided both in Classic and in the APIs for producing modern Metro-style applications. The way this is set up right now is you get events, and you get an event, okay, the point that was pressed or clicked, but the way the API is set up is you don't need to worry about whether that was a finger that caused the event, or a stylus, or even a mouse click. At the top level of the API, it's abstracted, so you don't have to worry about that. And what that means is that your applications, if you code them against that API, will by default be agnostic to the particular input device that's being used, and you will get for free, touch, stylus, and mouse support on your application. Now, it's totally possible to then query those events if you need to find out specific information, like was this for sure a mouse or a finger. That can also be queried, but it's much easier to target the case where you're spanning all of those devices, because the same code will work across all of them. There are several talks on touch from the touch team here as well. The sensor APIs are also updated from Windows 7, and we've added the gyroscope option as well. And then there's this new Sensor Fusion API, which is a mechanism where the hardware is actually able to integrate the results from the gyros for rate information, how fast your device is turning. Accelerometer, changes in position, and the compass is another absolute change in orientation. There's a Sensor Fusion mechanism in there that combines all three of those values to produce what amounts to an estimate of the current orientation and position of the device, or at least orientation, that you can access just via a simple API call. And then, of course, we've added support for game controllers. So you could take your Xbox controller, plug it in to the USB port and be playing a game. I believe Marble Maze supports that as well. There's a separate talk on all of these that will go into a little more detail and actually have some source code about how you would call each of those APIs. Okay, so for audio and video, one of the things that's unique about the game space is that when we do all this optimization for graphics, and we try to make it so that when I draw something, the GPU is there doing 2 to 100 billion pixels a second, getting that data out to the screen as soon as possible. And it's important to have an audio system that works the same way. When I have a sound effect, like my marble hits the side of the maze, I need to have the click sound of that happen at exactly the time that the marble actually hits. It can't be half a second later or so on, because that destroys the illusion. It makes it look wrong. It makes the physical model that you're trying to communicate to the user not look physically correct. So that's somewhat in an alternative approach to the way typical music playback is done, or video playback is done. In many cases, the focus there is not so much on getting the event to happen as soon as possible, but making sure that all of those notes come back in exactly a smooth fashion with no glitches. And so the differences between the requirements for an audio API for playing back music and movies are different from the needs of an API, the focus of an API that's targeting an interactive scenario. So for that reason, we've taken the XAudio APIs, which used to be on the Xbox, and provided them as part of this platform just to solve this specific problem of interactive low latency audio. Now that's good, but there are still cases where say I'm playing the background music, like we had the entertainer running during that Marble Maze program. That's a use case where you don't necessarily care that the music plays immediately. It's okay that it takes half a second to start. And then you want something that's just going to be a minimal amount of API and something that'll keep it flowing smoothly in the background. And Media Foundation is optimal for that, right? That's really what it was designed for. So we've got 2 optimal solutions for each of those 2 scenarios. Also with Media Foundation, if you've got, say, high-quality rendering, or in some cases games are using live-action cutscenes, you have the Media Foundation video playback technology, which, it's a very powerful solution. It's underlying all of the video playback technologies, all the way from the HTML video tag to Windows Movie Player and so on. And that's also available. There's another talk on these 2 areas, video and audio in games, by Jason Strayer, number 755. Okay, now, as I talked a lot earlier about this objective of focusing on latency latency which is how do I make an application that's as responsive as possible? And that's an example of the differences in a game application that cause you to focus on the type of architecture I'm describing in this slide. Fundamentally, what you need to do is have an initialization phase where you try to get as much done as possible so that the activity that happens in your main loop is as minimal as possible, right? So in many cases, we will do a lot of pre-processing to data. We'll be organizing data structures. We'll be making sure that we get information into not just system memory, but in some cases video memory. And so it's graphics optimized format, or in some cases audio optimized formats, in a way that once I start incorporating it in the main loop, it's the minimum possible amount of work has to happen every frame. Okay, now I said frame, and that's another interesting point. There's a variety of applications out there, even games, that are what you would call more event-based. So if I'm doing a chess application, or Sudoku, or Go, or Minesweeper, or Hearts, by default, the scene is static. And when I make a move, like I move a character or a card, then things update, and then they go back to static again. And so in that sort of model, the application by default state is to wait for the user to do something. There's another type of application which is pretty much only found in games, and where you basically recognize that instead of being static, almost everything that happens on that screen, every pixel, every sound, is pretty much changing all the time. And therefore, there's no point in optimizing for a static case. You might as well just run the entire application continuously in that loop. And that's what this main loop is describing here. This is a case where I want to run this loop at 60 frames a second, and I want everything in that to change. And this is also something that's very common in 3D games, because you're really doing an animation all the time. When you're doing a 3D application, turns out the dominant cue for humans to perceive depth is movement, which is why people crane their necks when they're at a parade, right? It helps with that depth perception. And it's something that doesn't work if the content is not moving. So that's why a lot of these games have ways for the character to move the camera around, move their position around side to side, and that helps the player understand where they are in space. But for that to work, every time they move the camera, every 16 milliseconds, you have to update and redraw the entire world, every single pixel on the screen, completely from scratch, from that new camera position. And so in that case, you really don't ever want to enter a state where things are static. So the way we do this in code is I didn't show most of the initialization stuff, but there's effectively a main loop that contains these steps. And the special one is we have this is using the C++ API interface into the object we call the core window, which is effectively the analog to the old message pump APIs. And just as there used to be a peak message approach, which would let me just say, okay, are there any events in the pipeline? If so, I'll process them. If not, then let's run this loop again, because the person has probably moved the camera and it's time to keep things moving and redrawing and keep the other, like the enemies, moving and so on. So we have to have this continuous loop. And the analog for that in the new API is this new token where we have an API call that processes events. And if you say, okay, if present, you have process all if present, that means it won't block. It will just keep going, and you can keep running around that loop. And that way you update your animated state, say the AIs of the other creatures in the world. You can update your graphics then based on their new positions, and you can present that information on the screen. That'll keep happening pretty much continuously. Now, it turns out that that last function, present, is designed to be something that blocks, but only for the time remaining in the vertical refresh that you've got. So this code here will automatically sync effectively to the monitor refresh rate, and you'll be rendering at the maximum rate that your device can handle based on its refresh settings, which is usually around 60 frames a second. Now, if you wanted to do a more conventional application, you would just use the process all option and not use the if present, and then it would block, and then you could be like Hearts or Solitaire or something where you don't execute the rest of that loop until it's necessary. Okay, so that's really sort of the game-specific technologies that we've got in the platform today. And we're now going to talk about a phase of solutions that are pretty much part of being an application on the platform itself. Because every good game is also a good application. And to be a good Metro-style application, we all need to follow the tenets espoused by Jensen yesterday, and really, show off to the user that the application is participating fully in the way the platform works. And there's a strong incentive for even games to do this, which is, if I just wanted to do something minimal, I'd go download some Flash or some other minimal game off of CNET for freeware, and it would probably run on my machine. But the user's not going to pay money for that. That's freeware. If they pay for an application, they're going to expect it to behave like a real application. So it needs to actually behave in that way for you to make money. So these are some of the steps that I want to highlight. Now, to some extent, the conference that we've already looked at is an solution to all of these problems. But I'm going to point through some of the more game-specific aspects of these. I mean, these should all be terms that are fairly familiar from other talks that you may have heard already at the conference. Okay, so at activation time, there is this splash screen. And it's been pretty traditional for all games to use a splash screen when they start up. In many cases, they'll show the publisher's name or the developer's name or something. And so you get to specify a splash screen for your application. It goes in the package. The Visual Studio tool will pack it in there for you. And the way it works is even unlike the way existing games work, the operating system knows that that is your splash screen, and it can bring it up before it even starts to load the rest of your application into memory. Today, with a conventional application, your application has to load before it can put up its own splash screen, and so there's that dead period where the user isn't quite certain, did I really click on that or not? So the advantage to that is that it covers up the time. It gives the user a cue that their request to start your application was actually received by somebody and that it's being worked on. So it's important to give that kind of responsive impact on the user. Now, the other thing that happens is that you're then going to have to, now you've got your application up and running, you're going to have to load some assets. And games are typically the types of applications that have the most data that they have to load into memory. That's again because you want to optimize that data as much as possible so that when you're actually running, you're not doing any work that isn't absolutely necessary. However, there is a limit to how long you can spend loading data on synchronous API calls, because the operating system is wanting to guarantee that the user will have a positive experience, and if the application doesn't do anything for a long time, they'll believe that it's hung. So what we've done is instituted some logic that will discourage applications from taking too long to load. So what that means is you need to actually then put up your own official splash screen, probably with a progress bar, so that the user can actually see the effort that you're doing and the time, and that there is actually work going on their behalf. And then also that tells the OS that you're still there. So this is the way our samples work, as in we just load everything at the beginning. Now, the problem with that is, I mean, this works okay for the samples because they're typically loading a cube and a very small texture. So we don't recommend that for anything in terms of an official application. A more sophisticated approach, and one that actually will be beneficial in more cases, is, like I said, to go ahead and start up a progress screen or some other application screen. This is really a version of your existing main loop. You're running that loop, and in that loop, you're really only updating your progress bar. But you know, there are a lot of people who've been very creative at how to create a progress bar. Now, in an ideal world, people wouldn't sit around with their thumbs or so on, twiddling their thumbs, watching the progress bar progress. They would be able to get into the game right away. So what would happen is, ideally, you would load the minimum that you need to render that initial scene, and then use background asynchronous processes to load in the assets that will be expected to be needed in the future. There you have to be a little bit careful not to introduce glitches in your main application thread, but it looks like it works pretty well. And then, of course, the ultimate technique is to not do file I/O, just procedurally generate your content on the fly. Now, I believe there's also been some information about how the operating system handles suspended applications. And really what happens is, this is equivalent to losing focus or becoming iconified to some extent in the Windows 7 case. What happens is, if you've been completely obscured from the screen, the OS immediately suspends your application. Now, you can actually request a deferral of up to 5 seconds, during which you can do some emergency work, but you've really got to make sure you make that deadline, because there's a possibility that once you're suspended after that 5-second deadline, your application will be there in memory, but it will not receive any clock cycles from the scheduler. So it'll be effectively suspended, as in just stopped. And that's the polite thing, because we want those cycles available to keep the battery alive and then potentially run whatever application the user has got as their full screen, or whatever it was that was now replaced and is the reason why your application is no longer visible. Now, so once you're suspended, there's two possibilities that can happen after that. One is you can get resumed, which means you just start getting called again, all your state's there, the player starts playing again, say they pull it back out, and everything's fine. But there is also a chance that your application will be terminated. And that means that the memory that's stored in the system memory will be cleared and turned over to some other application. And in that case, you're not notified. It's just that the next time you start up your application, you'll see, okay, I was maybe terminated last time. I didn't get to shut down any other way. Okay, so now what this means is when you're suspended, you should stop rendering because you really don't have time to do any rendering, and you need to save any state that wasn't saved already. Hopefully some was saved already. And then you need to free up any system memory resources that you could easily recover when you're resumed, for example. So there's a lot of cases where we've got some buffer and I'm copying stuff into it and out of it every frame, and it's just sort of scratch memory. If I can turn that back over to the OS with a free, then that's a good thing, because applications are terminated in the order of whoever is using the most memory. So the application that's more successful at reducing its actual memory footprint while suspended will be less likely to be terminated. There's potentially a case that some number of applications will be able to be suspended at the same time. And even though games take up a lot of memory, if a lot of it is scratch or can be freed, you've got a better chance of not getting actually terminated. And the advantage, the important factor there is that when the user switches back to your game, if you got terminated, you're going to have to go through your whole loading process again. If you just got suspended, you won't. And so from the user's perspective, your game is much more responsive. And from their impression of it, the number of stars they give it in the rankings will be higher, the more likely it is that you're coming back from just a suspend as from a terminate. And it turns out that it's pretty easy to handle this. There's the code that shows how to get the referral, but at the top you register an event just like any of the other events, like mouse down or so on, using this is actually C++, but it's using some of the syntax which was now been rationalized with C#, so that we're finding that people are taking existing C# code and pasting it into these samples, and it just runs. So I'm sure there are cases where there's many compile errors, but in general, it's architecturally very similar. Now, so we're being terminated, or at least being suspended. How do we save our state? So again, this is what our samples do, because they're very, very minimal applications. We want those to be thought of more as like a seed for you to build on than really a completed framework. So one of the options is whenever I get to a level, end of level, say, I would just save at that point. And the problem with that is if I'm suspended, I'm fine, because I'll get back and I'll be wherever I was. But if I got terminated and I have to resume and my last save point was at the beginning of the level, that means that the player has to start over that level when they got started after a terminate. And this is bad because the objective of this platform is to not have users be aware of the difference between termination and suspended. What happens as far as they're concerned, when the application comes back, it took a lot longer sometimes, and I had to start over level sometimes, and other times I didn't have to start over level. So from their perspective, it's like, this guy doesn't know how to write his code. So that's why it's very important for us to not recommend that particular approach. And what we need to try to do is get applications to save as close as you can to the end of where you are during the suspend. And in many cases, though, this means that you will not be able to save out an entire multi-megabyte save game at that point because you've only got 5 seconds. So the recommendation there is that whenever you get a chance, save the state that you've got. And so a chance means a place where the user won't mind, really. So at a checkpoint, at the end of a level for sure, at a case where they pause and go check a menu option and come back, at a point where they've achieved a major achievement and you're doing a little victory dance mode or something. Those are cases where it's a good opportunity to do that. And the more often you're able to do that, the less work you're going to have to do during the suspend callback. And again, If you can do these using asynchronous calls, then you'll have much less impact on the actual experience that's going on in the foreground. There's a separate talk on this, on how to do the asynchronous I/O, number 891. Now, how should a game handle some of these other operating system capabilities? In the way these come across, the screen orientations, like landscape and portrait, are effectively just resize events. There's a callback just registered with the plus equals, and we use that today whenever we switch to a different monitor, we get a different size, or the user could potentially change the resolution somehow. And so the code restructures the display based on the size that it's going to handle. And you get one of those also if the operating system is doing the automatic rotation based on the accelerometer. However, you can elect not to receive those types of events. And what that means is now it's up to you if you want to handle the rotation or not. And that's particularly important if you've got an accelerometer-based game. So something like Marble Maze or some of these other ones, when you're rotating the world yourself based on the orientation and the accelerometer, it's very disruptive to have also then your application get rotated again on top of that by the operating system. So you need to make sure that you turn off that capability before you implement your own. And the other interesting feature is, typical games today, like a high-end shooter, will be a full-screen application. You can run them windowed. You'll have your, typically your Skype client or something else in there as well. So we support that with the filled option in the middle. But then there's this third option on the left called snapped, where your game could potentially be the very narrow display. And there are plenty of games where the controllability now, or the ability to play, is just not really there at that point. So you need to probably go into, if you've got a very high performance game, an interactive real-time game, you're going to want to pause it, maybe automatically, put up a little message saying paused, and then when the user stretches back to full and they can play it again, you probably don't want to immediately unpause then. You want to give them the option to tap on the unpause button or the pause button or something so that they're ready to play, because the bullets could be starting to fly immediately after that. Okay, another cool new feature is this concept of a live tile. And these are, Jensen talked a lot about them, a way for your application to be not just present in the start menu, but actually participating in the start menu. So it can be some place that you go to find out information and just be notified of the status of your participation in the game, for example. Tube Rider is one of the titles that's already on your machine, and it does this. That's the live tile from Tube Rider. And it's updated fairly often with information about how far you've gone and what you need to do to get to the next level and so on. And that's this positive way to remind the user that your game is still there and they were recently playing it, and they might want to play it again. So it's up to you to find the interesting information to put in there that's going to bring the people back and make them want to start playing that game again. Now, the other similar thing is this concept of a notification, which is a toast-like message that comes up from the bottom right of the screen. And these might be something where if the user has said, okay, remind me when my raid starts, or remind me when so-and-so is logged back on so I can play with him. That's when you can use this notification technique. But our recommendation is that the game should not start spamming toast at times when it has decided it should do so. It must be something where the user has requested an alarm or a notification from that event, from that game via the settings panel or something. And yes, there's a detailed talk on that as well. So also, every game out there typically will have a settings pane where you can change options like maybe difficulty level or something like that. And so this is an example of a settings pane that kind of came out for a Sudoku app. It's been slid out from the right side based on the charms bar, which I'm sure you've all experienced on your preview device. And when the user selects say, for example, you can list about 4 options on that settings menu that are specific to your application. And then when, say, the user picks one that says game options, that's when you can bring up your specific game options tab as well, and then have settings that are specific to that title. Like, do I want to have sound effects happen at all during this game? Do I want to have an AI help me? Do I want to set the difficulty level to be really high? And this is, the advantage of this is it means that every application, the user will be able to find the settings. A lot of users can get really frustrated if they can't find the settings, and if every game puts them in a different place. I personally have been frustrated by this on a few occasions. So by having this standard, we help encourage that your users will be able to set the game up the way they like it. Now, one of the things that we're trying to do with this, though, is we're trying to be minimalist. We're trying to not clutter up the user interface with information if it's not absolutely necessary to convey that information. So in particular, what we'd like to do, say, for graphics quality settings, is most games, you don't want to ask the user for the really detailed settings, like should I run at 4xMSAA or anisotropic on-off, all those settings. What we like people to do is estimate a default value based on the hardware that's in the machine at that point, and not keep asking the user or expect the user to ask that. That's one of the topics that's covered in the 752 talk on Friday. And then, there's not much point in putting redundant features in there. If I've got a volume knob on my OS, then I don't need to also have one in the game. Unless I want to make sure that it's a volume knob that, say, only applies to that game, right? So we don't need to clutter our UIs up with redundant controls. Okay, another thing that gamers like to do often is brag about what they've done. So here I am, I made it to the top of this, I'm standing on top of this building, or I've just accomplished some achievement and there's a little trophy over my head. They want to take a screenshot of that and they want to get it up on Facebook or save it in their My Pictures library. So this is a good thing to support, and there are a lot of capabilities in the platform provided for those types of scenarios, not just for still images, but potentially you have the option to actually post little snippets of the gameplay. Someone has a particular thing that they've accomplished, they can record that whole clip potentially, if you're good at recording your gameplay, and then you could use the sharing contract to have them post that on YouTube or Facebook pretty much immediately. So a lot of games nowadays take advantage of the internet and support things like collaborative or even competitive multiplayer. And that's a very good thing to do. It helps your app grow virally. If other people are going to play it with you, then the chance that they'll have some friends and you can actually spread out the number of people playing your application. So there are a variety of APIs that have been provided. There's the WinRT API layer has got some updated socket capabilities, which include some automated or more automated NAT traversal. There's a separate talk on that. That's absolutely the correct approach to doing low latency communication between multiple games, say for collaborative play. And then also there's a set of APIs that the Xbox Live libraries will deliver, and that's going to be mentioned in Avi's talk tomorrow, I believe 10:30 in Ballroom D upstairs. He'll talk about a variety of technologies that will be coming from the Xbox Live people. And not only sort of those are the sort of the immediate networking things, like, during my gameplay I'm moving towards another player or getting updates of position from them. But there's a whole spectrum of even broader internet style services, like your Live ID, for example. One of the interesting aspects is that a lot of games out there today ask you to type in your player name so they know who you are, and to do that requires a keyboard. And it's a lot of pain on a small device to have to find a keyboard or bring up a virtual keyboard. So if you know the player's Live ID, which pretty much is always going to be there, you can save them that step and give them a nice default and save a bunch of complexity from the user's perspective. SkyDrive is something we'll talk about in a little bit, but it's something where you can leverage a variety of APIs to persist state, for example. And then Windows 8 has this automated roaming capability, which will allow your application's settings and some small amount of information to be synchronized automatically across multiple machines that you've, say, installed that same application on. And of course, there's the whole store. It's not open yet, but the platform that it represents has a variety of interesting internet-style technologies that will help your application be distributed and potentially provide information like telemetry and so on. This is another ping for the Xbox Live talk because they also provide offline networking services such as matchmaking, achievements, gamer score. Those are types of things that are part of this broader web approach of trying to make your application feel continuously connected so that it's part of the world at large. And then also there's a talk on how to do some social gaming using Azure backend as well. Okay, I mentioned roaming state, and this is a little bit tricky because while there is really good support in the operating system for synchronizing these folders, the app data roaming folders between all the machines that say that application is installed on, it's limited to about 30 kbytes. So what that means is that you don't want to put your whole save game in there. What you want to do is store URLs or links to save games that you then put on, say, SkyDrive. And that way, your application will be able to roam save games so I can play on my little tablet. When I get home, I'm running on my Media Center PC, my home theater PC, or I'm running on my desktop. Whenever I log into that machine, it goes and looks in the roaming state to get the URL and then downloads the full save game, my latest save game from the cloud using the SkyDrive, for example. And then I believe there's also a set of technologies there from the Xbox people as well. And that should be Capital Live. Okay, now, again, I was saying the high-end game companies spend a huge amount of work on their tools and their development process. And we wanted to deliver a solution that at least is, again, the seed of a more sophisticated approach. So we believe we've got all the pieces in place, and they're a good place for you to build on. But the real key to this is the amount of work that we've done in Windows in collaboration with the developer division teams. It's been a really rewarding experience, I have to say, that level of collaboration. And so what it amounts to is developer division has done a huge amount of work in their tools to enable this scenario for Windows. And so I'm just going to list some of the things that they've done as part of this. The first thing they've done is they've updated the C++ language to add all these new syntactic capabilities to handle COM interfaces the way we've got with automated ref counting, for example, so that it gives you the syntactic simplicity of other languages like, say, C#, but without the risk of, say, a garbage collector kicking on at some point and causing a glitch in your gameplay. Because the memory management is all handled using reference counting, it's much less likely to incur that type of a scenario. Another thing they've done for us is, they've also updated the syntax to allow you to do these things like event handling or registry and pointer management in a way that's not syntactically complicated either. They've also added explicit templates that you can go in there today on your device and say, file new project, Direct3D, C++, and you get, the full framework is already there. It doesn't draw anything, but it's all the pieces are there and it'll actually run right out of the box. That's very similar to the technology that's in our samples. They've also done a bunch of work to enable HLSL, which is the GPU language that all of our graphics is written in. And now HLSL files are treated in the IDE just like C++ or XAML or any other language that we support. So I can edit that and I hit F5 and it recompiles and puts it in the package and everything just works. Yes, having the package be built for us, and then understanding these types of assets, which is not just shaders, but potentially also textures and audio files and 3D meshes, and having those all be treated inside the IDE, so I can say, okay, this goes in the package, this doesn't go in the package, and then they've also added visualization tools that let me say, okay, my artist guy sent me this image and he wants it to go in the program, and I add it to my project, and then I look at it, is it the right image or not? So if you just mouse over it or select preview or properties, you'll be able to bring up an actual image of that texture, and you'll be able to verify that what you're building is actually what your artist wants you to be building. And there's a talk on the whole process here, number 761. In addition to that, I think they demoed in Jason Zander's talk this morning the ability to debug the graphics API calls that we make through DirectX. For a given pixel on the screen, you can go back and see what API calls were made that caused that pixel to produce the result it did. And you can use that as, it's almost like an inspection tool. It's like with the HTML stuff, I can click on some object in my expressions view or something, and then it will show me the code that created that object. In the same way here, we have the ability to look at some 3D scene, some object or pixel in that scene. I can go back and find out what calls were the ones responsible for creating that object as well. Very nice experience. Okay, so this is the slide I used at the beginning. I identified these as all being interesting pieces to put in a game. Some cases they're absolutely critical. And what I'd like to summarize is that for each of those pieces, we do actually have a component that will solve that problem, or at least be a good foundation for people who want to solve that problem. And so the summary is that Windows 8 does provide all the features that you need to create a Metro-style application. And so I think that if you're contemplating building a game today and you really want to get started, you probably want to attend a few more of the talks that are out there, but there's no reason to not start, tonight. And the other thing I've done here is I've compiled together, I believe, my game developer cheat sheet, which is kind of an index into the rest of the show, in terms of what are the different applications and samples that you could look at for each of these technologies or solutions on that graph, and then what are the talks that cover the specific features that are present there. So the thing I want to point out is that on that right-hand column, if you do something like go into your App Hub and you search for simple or 3D, or specifically in this case, resource loading, you'll get a whole set of probably about a half a dozen samples that demonstrate a lot of the technologies that we've got in this product today. The samples range from a very simplistic tutorial that just shows the basics of how to initialize an application and fire up the graphics API in a native way, all the way through doing things like loading complicated assets like three-dimensional model files, hooking up touch controls, hooking up joystick controls, hooking up audio for sound effects, audio for playback. And then on top of that, we've got applications like you have the Source to Marble Maze, which is a single end-to-end application that shows the whole spectrum of all of those different things in one code base. And so you can tell how they interact with each other. You can see, okay, inside my physics code, I need to have a case where when I detect that the marble collided with a wall, then I have to make a call to my sound system there to notify the user that that sound, knocking sound has to happen at that point. And so we wanted to make sure that no matter how you like to think, if you want to just look at a specific technology like touch or audio, there was an individual sample that showed that. And then there was also an end-to-end one. And the tricky bit is that those individual samples that show one particular technique, they're not full-on good Metro-style apps. Because if they had done everything that a real Metro-style app should be, you wouldn't be able to find the piece of code that we're trying to communicate that specific technology about. But anyway, that's kind of an overview of the resources that we've got. And So there's, like I said, there's a couple more talks at the show. There's Avi's, there's one more on input, one more on audio and video. And then I've got one on 3D. We've got another one on Friday on high performance 3D and optimization. So this is kind of the track spectrum of talks for games. And with that, I'm going to finish here, but I want to make it clear that anybody who has any questions, you can come up at the end. We'll talk about stuff that we were supposed to go down to the snack area and have our Q&A, but I don't know if that's going to be open right now, so we can do Q&A up here. And it's been great. It's been a great audience. Thank you.